Hello guys, welcome to my channel. You are watching Rathin Datta channel and I am Rathin Datta. This time we'll be discussing balancing of several masses with a balanced mass in the same plane. So let's suppose there are four unbalanced masses M1, M2 and M3 and M4. These are producing a resultant centrifugal force, suppose FCR. Okay, this resultant FCR has to be balanced by another mass which we will be calling as balanced mass. Let's suppose call it as MB, M suffix B. It will produce its own centrifugal force. Let's suppose called it FCB. This FCB will neutralize the FCR, the unbalanced resultant force. So it is quite obvious that these two forces will be equal in magnitude but opposite in nature, so that we can neutralize or balance in the unbalanced centrifugal force in the system. For this we will be drawing a force polygon. The closing side of the force polygon will give us the magnitude for the required balanced centrifugal force FCB. That means if we get the value of the resultant FCR, that will be directly equal to FCB, and if we know the radius of the balanced mass, we can easily find out the magnitude of the mass of the balanced mass. So our main target or aim will be to find out the magnitude of the balanced mass, that is MB, and to find out the position of the balanced mass, that is theta B. So we will be finding out MB and theta B, because whatever force it will generate, this balanced mass will actually neutralizes the unbalanced resultant force FCR in the system. Let's see how we do it. Hello guys, this is the thing I was explaining in the first part of the video. As you can see, we are discussing the balancing of several masses in the same plane. Okay, you can see the arrangement which we are calling it as in the left hand side portion of the screen, that is called configuration diagram. We are calling it as a configuration diagram, means we are showing the places or the positions of the masses as per the thing. As you can see, the first mass M1 is at theta 1, the second mass M2 is at theta 2, the third mass is at theta 3, okay, and the last mass is at theta 4. Okay, theta 1, theta 2, theta 3, this one is theta 3 actually, okay, and this one is theta 4. These are the position of the masses, unbalanced masses, okay, and these are the respective R1, R2, R3, R4 are the respective radius of rotation of those masses. And as you can see, these are the unbalanced forces developed, FC1, FC2, FC3 and FC4. Okay, what will it will do, all these things, FC1, FC2, FC3, FC4, all these forces will create a unbalanced resultant force. As you can see, for now we don't know actually the position of FCR. Okay, we will actually find it later on, this FCR. So we know that there will be a FCR, that is resultant centrifugal force, but yet we don't know the position of FCR. So what we have to do, using this configuration diagram, we have to draw this one. The middle portion of the screen, as you can see, is the force polygon using the vectors. As you can see, the mass M1 is at theta 1 degree. So keeping this as a baseline, we draw a line that is of same angle as theta 1 from O to A and name it as FC1. And with theta 2 for the mass M2, using this angle, this 90-degree angle, we draw a line A to B. And for the third mass M3, using this line, the M3 line, we draw a line from B to C. At each point you can see we have drawn a baseline, that is the line OX. From this line all angles are taken anti-clockwise. You can see all are anti-clockwise, all are anti-clockwise, all are anti-clockwise, all are anti-clockwise, you can see, and the respective angles are actually taken. For M1 theta 1, for M2 theta 2, for M3 theta 3, for M4 theta 4, the respective angles, right? And finally we come to a point D where we actually close the polygon using D naught. As you can see, this line D naught vector, this is the closing line in the force polygon. So we obviously know this will be the direction of the FCR, the resultant centrifugal force. So the equal and opposite force, that is FCB, will be just like that I have shown, just to the opposite of FCR. So your FCR will be equal to FCB, and FCB is nothing but MB into RB, is it not? But your FCR, whatever lines we have drawn, this OA, AB, this CB, all these lines have to be drawn with certain scale. Scale you can choose of your own. Like we have taken this FCR, that is the resultant force, is nothing but the vector DO into scale. As you can see, this scale is nothing but, suppose your M1R1 is suppose 20 kg meter. Okay, M1R1, the product is 20 kg meter, and we have taken 10 kg meter equal to 1 centimeter. It means if we draw this FC1, this FC1, if we draw, how much we have to draw? This FC1 will be nothing but 2 centimeter, because 10 kg meter equal to 1 centimeter, so 20 kg meter will be 2 centimeter. So this line OA will be 2 centimeter, and hence in this way we have to draw the entire force polygon and we have to finally come up with FCR, and we have to just take the opposite of it, that will give us FCB. So once it is done, this MB will be FCB into RB. FCB can be actually be derived from FCR using this scale. Once we convert this scale, we have to put this FCR value here. Okay, here FCR value. So when you know RB, so you can actually find out your MB equal to FCB by RB. So in the point D, using this direction, the direction of FCB, the lower direction, from this the horizontal line at point D, we can actually find out the angle theta B. As you can see, theta B. Okay, so we do know now that this line, the position of the FCR will be this one. As you have in the left hand side portion, you can see this FCR will be this one. So your MB will be here. So this will give us FCB using RB and MB. This FCB will balance this FCR, and hence FCR is equal to FCB into equal to MB into RB. So we find out this mass MB and we found out this theta B, which are the two aims to find out. So by this way we can actually balance several masses, in our case is M1, M2, M3, M4, by a balanced mass, that is MB. I hope you have got the concept, and once again thank you so much for subscribing, for liking and for sharing. Please hit the bell button because it inspires me. Thank you so much. Bye bye.